Hello students, welcome to the automobile engine class. Myself Shankho Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandrasur Degree Engineering College under the JIS group. So students, here in the previous few classes, we covered the five module from these chapters. So for the five module, when we are taught taking the first module that covered the about the engine principles and the fundamentals. Then we study. Then we study about the second module. In case of the second module, we study about the constructional features, function, and the working of the automobile component. Now, in the third module, we already covered about the engine cooling system. Then, in the fourth module, we already covered about the engine lubrication system. After that, on the fifth module, there is two sections are available. First one is section A, which is covered the fuel fed system in petrol engine, and in the second and B section B, that covered the fuel fed system in diesel engine. So students, these modules were already covered in the previous few classes. Now, from this today, we started the class with the module number 6, and the topic is engine performance and testing. Before we started the class, we just inform you the objective and the outcomes of this subject. So students, the objective of an engine performance and testing classes are students can easily understand about the various kinds of parameters which helps to calculate the engine performance as well as engine efficiency, and they can also understand about the measurement of various types of power which is connected in this engine, means such as indicated power, brake power, and the fabrication and the frictional power. They can easily understand about the dynamometer, and they can understand about to the heat balance sheet and the performance characteristics graph. So students, these are the objectives of these subjects, and the outcomes of the subjects are students can easily identify the parameter of the engine performance and the testing related. Then they can easily solve the various kinds of numerical those are connected with this engine parameter and the engine testing. So that's why we are studying, we are here to discuss this module, which is covered your six module number 6, and the topic is engine performance and testing. So students, let's start the today's class. In the IC engine or the internal combustion engine generally operates within a useful range of speed. So some engines are made to run at a fixed speed, meant to run at a fixed speed by means of the speed governor. What is this rated speed? So at each speed within the useful range of the power output vary, and it was the maximum useful value. So the ratio of the power were developed to maximum useful power, the ratio of the power where the maximum usable power at the same speed is called the law. So students, here in this basic task during the design and the development of the engine, or to reduce the cost of the production and improvement the efficiency of the engine and the power output, we need to know about the various kinds of factors those are related with this engine. So this engine performance or engine testing basically covers about the following points. Means here we can find out or study about the power input and power output. So how can calculate the power input power and how can calculate the output powers from the engine. Then we can understand about the various types of engine efficiency, means the indicated thermal efficiency, the brake thermal efficiency, engine efficiency, volumetric efficiency. And we already know that some pressure is required to complete the principle of the IC engine. So for that reason we need to know calculate to find out the mean effective pressure. After that we need study about the engine speed, fuel consumption, air fuel ratio, and the calorific value. So these are the main requirement when we are talking about the engine performance and the engine testing. So here we started with the discussion with the engine parameters. When we are talking about the engine parameters, these following parameters take a important role, such as bore, piston area, stroke to bore ratio, clearance volume, swept volume, total volume, compression ratio, and the engine torque. So these are the main engine parameters which is need to know when we are going to design an engine, or when we are going to reduce the cost of the engine. We want to improve the engine efficiency, as well as we also want to improve the power output. So these are the main parameters which is taken important role for this purpose. So students, let's start with this bore. So bore is basically defined as the nominal inner diameter. The bore is basically defined as a nominal inner diameter of the working cycle. So this is called the cylinder bore. So or the cylinder bore we can say as in the diameter of the cylinder. When we are talking about the diameter of the cylinder, so that is similar to the bore, or that diameter of the cylinder is also called as a bore. So this bore, as it is designated by the letter D, and the bore is designated by the letter small d, and it is expressed in millimeter unit, and when the short form of the millimeter is mm. So when you have to calculate some equations or some numerical, so that time the bore is denoted by the small d, and it is expressed by the mm, means millimeter. Now coming to the next parameter, that is the piston area. When we are talking about the piston area, basically the area of circle of a diameter, which is equal to the cylinder bore, is called the piston area. Thus, because of the piston is fitted into the the piston is fit into the cylinder wall or the combustion chamber. So that's why the combustion chambers or the cylinders inner diameter and the piston head diameter are nearly same. So that's why we are calculate that the cylinder bore or the diameter of the cylinder, inner diameter of the cylinder and the diameter of the piston are same. So when you are need to calculate the piston head area, so then that time we consume the cylinder inner diameter as the parameter. So that's why this cylinder diameter on the this is the cylinder diameter. When we calculate this area, and that area is called as an piston area. So this piston area is specifically designated by the letter A, and it is expressed in centimeter square, and it looks like cm to the power 2. And the equation to calculate the piston area, that's our A equals to pi by 4 d square. A equals to pi by 4 d square. So from this equation we calculate the piston area. Now coming to the next other parameters. So stroke is then another parameter. So next parameter is called known as the stroke. The stroke is basically nominal distance. The stroke is basically a nominal distance. The stroke which a working piston when it is moves in between two successive reversible of its direction. Basically means when piston moves from TDC to BDC or BDC to TDC. So this basically this length is called or known as the stroke length. So this stroke length is designated by the letter L, capital L, and it is expressed in millimeter or mm. Next is the stroke ratio. The stroke ratio basically is defined to classify the engine size. So here L means stroke length and D means bore. So L and D, the ratio of the L and D, define the classification of the size of engine. So if L is greater than D, means if the stroke length is greater than the bore diameter, then the engine is called the undersquare engine. If the L is smaller than the D, means stroke length is smaller than the cylinder bore, then the engine is called as an oversquare engine. When L and D are equal, means stroke length and the cylinder bore are equal, both are equal, then the engine is called as an square type engine. So here according to this, according to the ratio of the stroke length and the cylinder bore ratio, we can find out, classify the engine in various sizes. So now coming to the another components, another parameters are, the next parameters are clearance volume, swept volume and the total volume. When we are talking about the clearance volume, so basically the nominal volume of the combustion chamber above when the piston reaches at the TDC. So when is piston in the combustion chamber, when piston is placed at the TDC or top dead center, So the nominal volume is available. That volume is called as clearance volume. So this clearance volume are designated by the VC and expressed by Cc. Cc means cubic centimeter. The short form of the cubic centimeter is Cc. Then here talking about the swept. Next parameter is the swept volume. Swept volume means when the here is also talking about the nominal volume when the piston moves from TDC to BDC. So when the piston travels from TDC to BDC, so within this stroke length, the volume of the combustion chamber within this stroke length, the volume of the combustion chamber is called as the displacement volume or the swept volume. This volume is designated by the Vs and it is expressed in Cc. And the equation of this swept volume, that is Vs equals to pi by 4 d square L, or it can be calculated in this equation, that is Vs is equals to capital A into capital L, where A is the area of piston and L is the stroke length of the stroke. Next is coming to the total volume. The total volume is the summation of clearance volume and the swept volume is called the total volume. Means when piston is reached at the BDC or bottom dead center, then the total volume of the combustion chamber, from above the piston when it is at bottom dead center to the bottom of the cylinder head. So that whole area and the whole volume is called as the total volume, which is designated by the Vt and expressed in Cc. And the equation was Vt is equals to Vc plus Vs. So these are the volumes which is calculated or connected the into the combustion chamber. Now coming to the another slide. Here we discuss about the compression ratio. So when we are talking about the compression ratio, basically it is defined as the ratio of the total cylinder volume. It is defined as the ratio to the ratio of total volume, total cylinder volume of the piston when it is at BDC to the clearance volume when piston at then TDC. So this ratio is called as a compression ratio, and this is designated by the R, and the equation is R is equals to Vt by Vc, where Vt means we know the Vc plus Vs. Vc is the clearance volume and Vs is the swept volume. So Vc plus Vs by Vc. So from there we can find this equation, the 1 plus Vs by Vc. Then another parameter is known as the engine torque. The torque is basically a twisting or turning force. The torque is a twisting or a turning force. So it is basically the tendency. It is basically in the tendency of a force. This tendency of a force to rotate an object about an axis. So basically the torque is a torque, as it is a turning force. It tends to rotate an object. It tends to rotate an object with respect to an axis. So in case of the automobile, it is a measure of the rotational effect which is applied on the engine crankshaft by the piston. So with the help of the piston, how much rotational effort is applied into the crankshaft, that is called as the engine torque. So this torque basically is designated by the capital T and expressed in the Nm or Newton meter, in expressed Newton meter unit, and the equation was T torque T is equals to force into distance. So these are the main parameters which is connected with the engine when we are talking about the engine performance and the engine testing. Now coming to the next portions, which is connected also the engine performance and the engine power. This is now called as the engine power. There are the three types of engine powers are available: indicated power, brake power, frictional power, and beside this power they have also need to which another important parameters which is required to find out the engine power. This is the one called as an mean effective pressure. So students, let's start with this indicated power. The indicated power means the total power. Generated power means the total power which is developed by the combustion of fuel in the combustion chamber. So when the air and fuel mixture are burned or combust properly inside the combustion chamber, the amount of power is generated. That power is called as an indicated power. So this indicated power is designated by the IP and it is expressed by the kilowatt or kW. The equation of the indicated power, that is IP is equals to PIMP into L into A into N into K divided by 1000 into 60. Here PIMP means mean effective indicated mean effective pressure. So the PIMP is means indicated mean effective pressure. L means length of the stroke, A is the piston area, K is the number of cylinder. Here N, small n, means the number of power stroke generated in power a minute. Number of power strokes per minute here is generated. If it is in 4 stroke, then the n value is equals to capital N by 2, where capital N means the speed, engine speed in RPM, and when it is in 2 stroke, then the capital N, small n is equals to the capital N. Next is the brake power. Brake power means after the power produced inside the combustion chamber, how much amount of power is available at the engine output shaft, that is called the brake power. The power which is power is available in the engine output shaft is called as in brake power. So this brake power is designated by the BP, capital BP, and it is expressed in kilowatt unit, and the equation is the BP is equals to 2 pi nt into 1000 divided by 1000 into 60, where n is the speed of the engine and t is the torque of the engine. So after knowing these two power, now coming to the study of this indicated power. Next is coming to the frictional power. The frictional power is a power which is required to overcome the internal friction of the engine. Basically the power which is overcome the internal friction of the engine. So this is called as the frictional power. So the frictional power is designated by the FP and expressed in kilowatt unit. And it is equation is that frictional power is equals to IP minus BP. So basically the power difference in between the indicated power and the brake power is called the frictional power. Next is mean effective pressure. The mean effective pressure is average pressure. Mean effective pressure is the average pressure inside the cylinder. The mean effective pressure means the average pressure inside the cylinder of an IC engine, which is totally based on the calculation, based on the calculation of the power. So this is called the mean effective pressure, and the mean effective pressure is designated by PMP. When we are talking about the brake mean effective pressure, then it is designated by PIMP, or when brake mean effective pressure, then it is calling about the PBMP. It is expressed in the Newton per meter square unit. It is expressed in Newton per meter square unit. And the equation was that PMB was that which is found, which I found from the equation of the indicated power. So we find that the IP is equals to P MP into LANK divided by 100 into 60. So from there we find equation, we find out the PMP, and another equation is that the brake power. We also find that brake PMP is equals to BP into 100 is 1000 into 60 divided by 2 pi NT. So in this equation we calculate the mean effective pressure. So these are the important parameters which is helps to calculate the engine performance and the engine testing. After studying the various kinds of engine factors, engine power, now coming to the study about the engine efficiency. The engine here in engine efficiency, which is basically divided into the 5 portions, means indicated thermal efficiency, brake thermal efficiency, mechanical efficiency, volumetric efficiency, and relative efficiency. So students, here let's start with the indicated thermal efficiency. Indicated thermal efficiency is the ratio of energy in indicated power, the energy in indicated power to the energy to the input of the fuel energy, to the input of the fuel energy. So basically the ratio of the indicated power. So we already know that when you calculate the efficiency, it is defined as the output by the input. Here when we are talking about the indicated power is the output, and for the indicated to prepare to prepare the indicated power, we need some fuel energy, so which is the input of the thermal, which is input in the indicated power. So that's why here this equation is looks like that, in the ratio, looks like ratio of the energy in the input power, in indicated power, energy in the indicated power to the input of the fuel energy. So this is the indicated thermal efficiency. This is designated by the eta ITH, is the efficiency of indicated thermal efficiency, and the equation of this indicated thermal efficiency is IP divided by MF into CV, where MF is the mass flow rate of fuel into CV means calorific value of the fuel. And after getting the result, if we multiply the final result with the 100, we got the efficiency in percentage. In the percentage. Next is the brake thermal efficiency. The brake thermal efficiency is the ratio of the brake power to the indicated input to the input fuel energy. So this is designated by the eta BTH, and the equation is eta BTH is equals to brake power divided by mass flow rate of fuel into calorific value of the fuel. When we multiply into the 100, we got the brake thermal efficiency in a percentage unit. So here we discuss about the indicated and the brake thermal efficiency. Next is mechanical efficiency. The mechanical efficiency is the ratio of the brake power to the indicated power. The mechanical efficiency is the ratio of the brake power to the indicated power, and direct power, and this is designated by efficiency M, and the equation of efficiency equals to PP by IP. Next is the volumetric efficiency. The volumetric efficiency is defined as the volume flow rate of air into the intake system. Volume flow as the volume flow rate of air into the intake system, which is divided by the rate of air at which the volume is displaced. So volume is displaced. So this ratio is called as the volumetric efficiency, and it is designated by the eta V, and the equation is eta V is equals to MA into rho A into VD, where MA is the mass flow rate of air during the intake system, and air into the intake system, and the rho A is the air density, and Vd means the velocity of the displacement. So from that we calculate from this equation we calculate the volumetric efficiency. After that, the volumetric efficiency, next is relative efficiency or the efficiency ratio. So it is the ratio of the thermal efficiency of an actual cycle to the ideal cycle. So the ratio of the thermal efficiency on actual cycle to the ideal cycle is called as then relative efficiency or efficiency ratio, and this is designated by eta REL, or means relative. The equation is eta relative is equals to actual thermal efficiency divided by air standard thermal efficiency. So these are the main efficiency is take an important role when we are going to calculate the performance of the calculate and find out the performance of the engine. So students, here in the first part of the engine performance and testing, we discuss about the introduction of these engine parameters, and we also in the engine parameter we discuss about the various types of engine parameters and their equation and units and their designated expression. Then we will discuss about the engine power and their equation and their units. Then after that we discuss about the engine efficiency and their equation and the identification. On the next class we started with the discussion with the air fuel ratio and the indicator diagram. So till then, stay at home and stay safe. Thank you so much students.